Okay, so today we're talking about factoring. I want to start with a really easy one. 3x plus 15. Don't even write this one down. Just think. What goes into both of them? 3 goes into both of them. So I can pull the 3 out. What do I have left? X plus 5. Okay, that's factoring. I factored a 3 out of both of them. Now, when I say pulled a 3 out of both of them, it's like you yank the 3 out of here and I yank a 3 out of there. What am I really doing? I'm really dividing them by 3. See, when I divide this by 3, I get an x left, and that goes here. When I divide this one by 3, because I pulled it out front here, then I'm taking 15 divided by 3 and I put it there. Okay, I just want you to get what we're doing. So if I say 15x squared plus 10x, and I factor out not just a 5, yes, 5 goes into both of them, but what else goes into both of them? If I take out a 5x, I'm pulling it out, and I say it that way, but what am I really doing? I'm dividing by 5x. So if I divide this by 5x, when I'm done with that, I put it right here. Okay, so what would I put there? I need an x, yes. I need a 3. And now how can I be sure I'm right? All I have to do is do a quick multiply. That times that, and it should equal that. And so it's 15x squared. Yay, I did it right. So then 5x times what? 2. And is it positive or negative? So there it is. I factored it. See how you do that? All right, I want you to try one. 8x squared plus 4xy squared plus 12 x to the third. Factor that. Grab your pencil. You want to slip into a coma here. As much as I'm sure that book is interesting, set it aside. You're focusing on your math right now. The other thing is, I do the same thing when I'm allowed to. I'll set my cell phone out on the desk, but I would appreciate it if you would not. If you keep your cell phone in your pocket, that's fine. You're supposed to have it off. I'm not going to go there, but at least I know it's really tempting. You get a text. If it's in your pocket, you're going to be much less likely to be bold enough to pull it out and look at it, because if I catch you doing that, I'll take your phone. But if it's on your desk, you're going to be way too tempted. You're just going to be looking at it all out as your friends text you. All right, so just keep the cell phones away. They can be on, but just they're not supposed to be on, but I won't check that. All right, so what was in all of them? Do you agree that 2 was in all of them? But is there something even bigger than 2 in all of them? 4 was in all of them. So if you take a 4 out, that'd be smart. What else was in all of them? X, just one x? Yeah, because that one limits us to, there's only 1 in there, so that's the biggest we can take out. And then what do you have left? You just ask yourself, when I do this times this, I got to get that. So it better be 2, what? 2x plus 4, no, just y squared, right? Now double check that times that makes that. Yes. And then this times this, so what's that going to be? 3x squared. There we go. Done. All right, so that's simple factoring. All right, we're going to get into much more complicated factoring than that. Let's go to right here. All right, so this 12x squared plus 18xy minus 30y. What number can come out of all of those? 3 does, but something bigger also does. 6 goes into all of them. And can I get an x out of all of them? No. Can I get a y out of all of them? No. So then all you could really do is what? 6, and then you'd have what's left. Good enough. Let's move on to b. What can I pull out of both of those? X squared. If I pull an x squared out, you remember you're asking yourself, what goes here and what goes here, so that I can multiply it back out and get that. X to the third, and what? 1. Because now if I multiply this back out, it will give me. Okay? Next one. This is a little weirder. What do these guys have in common? X plus 3. They both have an x plus 3 in them. See, this one's got one, this one's got one. So then I can yank that x plus 3 out, put it in front, And then what do I have left when I yank it out? Remember, when I'm yanking it out, I'm really dividing by x plus 3. What would I have left? X squared. And it's probably be smart for me to put this in parentheses, because it wasn't parentheses the first one. See how when I divide by x plus 3, that'll cancel this, and I got x squared left. And I divide by x plus 3, and I'll cancel this, and I got a 5 left. There it is. All right, so again, this and this were in common. It came out to the front. And then I put a parenthesis, and when I see whatever's left here, which is that, here. Okay, moving on. Letter D is in donkey. This one's got 4 parts. If you have 4 parts, you need to do a special kind of factoring where you split this down the middle. I gotta leave that negative on the 6 because that's where the negative goes with. And now you do it 1 part at a time. You get that I could just ignore this stuff over here for a second and factor that first part. Do it. You already done? Okay. You can do stuff in your head, but then write it down. So I think 3 goes in both of them. I think x squared goes in both of them. 3x squared comes out, and then I got what left? X plus 5. All right. Now I'm going to reveal the other part. What goes into both of those? Just 6? Negative 6 goes into both of them. I like that idea. I'm going to take out a negative 6. And what do I have left? X plus 5. And why is it plus? Because this times this has to make negative 30. Get it? See? All right, and now look at this. They both have an x plus 5 in them. So now that can go out in front. Uh-oh, Smartboard's starting to freak out again. Making every other line a different color. And then, once that gets pulled out, I see what I have left. What I have left is 3x squared minus 6. And this is really a nasty one because I can factor it again. Do you see something left? Yes, in the second parentheses, I got a 3 in common here and here. So I can pull that 3 out. I wish I had more room here. I'm just going to scribble this out so I don't have to worry about it for now. And I'm going to say, all right, x plus 5 just comes down. It was fine. Change the colors again. And then this 3 can come out of both of those, so I'm going to put it here. And then what's left? X squared minus 2. It's a good question. If you don't simplify it all the way, you will lose the point. And the bad part is, you guys that have had Marzano before, I don't think he has, you know that if you get something wrong, it's just wrong. So you can't get partial credit. So you just get someone marked wrong if you didn't go all the way. On homework, I give you half for it, but on the test, this is going to be wrong. Gotta notice. And that is the toughest part. A lot of kids can factor part of it, and they just don't notice you can keep factoring. All right. Now, I want to talk about some tougher kinds of factoring here. Sum and difference of cubes. To really get this, I should talk about something else first. Difference of squares. Do you remember these? And you'd go, oh, it's a difference, minus, of something that's a perfect square and something else that's a perfect square. In other words, they have nice square roots. So I could go x and x, 4 and 4, and a plus and a minus. Do you remember that? Good. You did learn that last year. So that's called a difference of squares. So another one like that would be x squared minus 1. Even though a lot of people don't think of it that way, 1 has a perfect square root. What is it? 1. So this is the 1, this is the 1, this is an x, and this is an x, and then what do I do? Plus and a minus. Now how does that work again? Because the firsts make x squared. The outside and the inside are opposites of each other. Negative x and positive x, and they cancel. And the lasts make negative 1. All right, so it's x plus 1 and x minus 1. All right, one more complicated one, x to the 4th minus 4. You get how those are both perfect squares too? So it's just x squared and x squared, 2 plus and minus. All right, I got one more to give you, and I know half of you are going to get it right, and the other half are going to get it righter. You can see what I mean. Second. Factor that one. Here's the half of the class that got it right. X squared minus 1, x squared plus 1. But then the class has always got a few kids that can get it righter. Who knows what I'm talking about? Does anybody know what I can do to make this answer better? See, nobody sees it. It's just amazing. Yes? Nope. Thanks for guessing. That's all right. What do you think? That one right there can be factored again. Get it? What if I just put that on the board? You could factor it, right? So, x plus 1, x minus 1, and then this one's still left, and this one can't factor because it's a plus. There you go. Now that's factored all the way. And nobody saw it, but that's the thing. That's exactly what Jay in the front row was talking about. He was saying, and I only use the letters when I'm recording, so anyway. He was saying, hopefully your name isn't Bob Server, I have to say this. But anyway, if you get done with it and you factored it right, but what if you didn't factor it all the way? You get it marked wrong. You would have all had it marked wrong because you didn't notice that you could factor that farther. So now I'm down to 3 parts. All right. At this point, I think it'd be smart for me to start doing some of your homework with you. So I'm going to give you your homework, and we'll, instead of making up more practice problems, we'll just do some more with you. All right. Now, I'm not going to talk about difference of cubes today, and there's one question on that on here, and I'm going to tell you more about that tomorrow. But I feel like your brains are full enough for today. Sorry, Monday. All right. 6. 1, 2, 3, 4, 6. All right. Pause for a second. Okay, so back to our worksheet that I just gave you. The very first one, it looks kind of intimidating, but it's really not that bad. The only thing that might freak you out is what goes into 51 and 17. 17 does. You can assume it probably would, but it actually does. Negative 17x squared plus 51. You should be thinking, well, it's got to be 17 because 17 doesn't have any other factors other than 1, which doesn't help. So it's got to be 17. So you pull out a 17, and would it be smarter to pull out a negative 17? Yes, it would, because it'll leave our x squared not having a negative on it anymore. If I do this. Oh, I'm freaking out again. Every other letter is a different color. It's kind of like random day. Okay, and then this is an x squared, and this would be plus or minus. I think it's minus because minus a minus will make it a plus. See what I'm saying? And then what's that got to be in the blank there? 3. All right. And can I go farther? That should always be your question, because I know you're smart enough to do the factoring, but it's like nobody in the class noticed before. It's hard to go with the next one. And you ask yourself, could that factor more? No. What if that 3 was a 4? Then could it? Yes. All right. Good enough. Number 1's done. Number 2 is one of those kind where there's an x plus 4 in common. So it comes out to the front. And you pull out an x plus 4 to the front, and then I'm going to have an empty parenthesis here, and you figure out what's left and drop it in there. If you're really having trouble with what to put in the parentheses, do a little divide by x plus 4 on both terms and see what you have left. And that's what goes in here. I'll give you a hint, it's a minus. All right. Number 3 is one of those kind where I'm just going to tell you, I'm giving you some help, here, but I'm not just going to do them all for you. Number 3, it's one of those 4-part kind. If you want to do 4-part factoring, you've got to do the little divide it in half. There was a famous warrior who had a saying, divide and conquer. And it was a concept for a long time. Abraham Lincoln used it. He said, a house divided against itself cannot stand. Dividing something makes it weaker. So you divide this down, divide and conquer. Divide it into 2 parts. Factor this part, factor that part, and then hopefully you'll notice they have something in common and factor it again. Right? Number 8 is one of those kind that I did not teach you how to do. You may just like gently cross out 8. Don't scribble it out because we want to maybe do it later. 8, number 8. I'm not going to show you how to do that because your brain is already full enough. All right, and I will warn you, number 5 is brutal because there's so many different ways it could work. Let me show you. Number 5, it says 20x squared plus 53x plus 18. Well, first thing I would look for is there anything, since the numbers are so big, is there anything in common here, here, and here? And you think, well, maybe 2 goes into, oh, no, doesn't go in the middle one. Maybe 3 goes in, no, 3 doesn't go into this one. Maybe 4, but no, 4 doesn't go into 18. 9? No, 9 doesn't go into 20. And you realize nothing goes into any of them. So you can't factor anything out of them. So then you're stuck. It's a 3-part, so you can always do 2 sets of parentheses. So do that. And now you have too many choices. Okay? I could be doing, how do I make a 20? Give me some options. 10 and 2. There definitely needs to be an x here and here. But it could be 10 times 2 makes 20. Or what else could it be? 5 times 4. What else could it be? 20 times 1. There's so many choices. All right, this is just guess and check. Grind it out. The only good part is that they're all pluses. See, it's plus and plus, so then I know this is a plus and this is a plus. And then the 18, what could that be? Oh, so many things. 6 times 3. Could be 9 times 2. Okay, so let's say I throw in a 9 and a 2. How do I know if I'm right? You check. Now, the first and the last, we don't need to check, because we know that this times this makes 20x squared. And we know that this makes 18. We don't really need to check those. What you need to be checking is these. The outside and the inside, they make 53. Well, that's 18 plus 20 makes 38. So I need to make it bigger, right? What if I switch the 2 and the 9 around? Put a 2 here and 9 here. 9 times 10 is 90. That's too big. Be that. You get what I'm saying? Just guess and check. You just grind it out. There's really, yes, there are ways that we can teach you to solve these, but seriously, we spent 3 days teaching you how a method for solving and finding them, okay, and it wouldn't be worth it because you now know a method that you probably really realistically won't ever use because if you ever have one this hard in the real world and you're trying to factor it, you know what you're going to do? You're going to type it into your iPad, and there's a app for that. It'll factor it for you. Or you could go to Wolfram Alpha, which is a website. And all I have to do is type in an equation in Wolfram Alpha and hit enter, and it factors it. It's free. It's like Google. Yeah, that app is on the iPad. Yeah. So anyway, the point is, factoring is not a skill that you need to get super good at really hard ones, but the easy ones, you need to be able to do those fairly quickly. Once again, ACT is kind of important, right? ACT is a big test that you're going to be taking. That'll make a big difference in your life. On the ACT test, you are not allowed to use the internet or an iPad, only calculators. And these calculators that you have don't have a factoring engine in them. So you have to know how to basic factor. I guarantee you the ACT would never have anything this nasty to factor. So this is stretching you, and I'm telling you that ahead of time. This is really tough. What if it never works? Did you find it? Oh, cool. Don't tell anybody now, because then it takes away. I mean, I believe you. I mean, we all can believe that you checked it and you probably got it. But as soon as you tell them, well, and it's easy, right? They should have to struggle a little bit. Okay, so now back to the ACT test for just a second. I want to make sure you understand why that test is so important. Number one, if you do well on your ACT test, you do really well, you can get in any college you want to. It counts so much. It can basically, as long as your GPA isn't terrible, you're going to be able to go, if you get a really high ACT, you can go anywhere you want. And there's a lot of kids that can't. There's a lot of kids that want to go to a certain school and they can't because their ACT isn't high enough. Like, let's say you want to go, because all your friends are going to Madison, but your ACT isn't high enough. I mean, it kind of sucks. You can't, they just won't let you in unless your ACT's high. Okay, so if there's a reason you want to do well on this thing. All right, next thing is, let's say that the school you want to go to, you already got a high enough SAT to go in there. Well, sometimes for my son, for instance, he's interested in going to St. Thomas. And St. Thomas' tuition is 40 grand. He's got an ACT that's pretty good, but if I give him, I went into the website and they have this little deal. It says, what will your tuition be at St. Thomas? In other words, you may pay less than 40 grand if you're a good student. Well, he typed in his GPA, I typed it in, and I typed in his ACT, and it says that the 40 grand goes down to 28 grand because he's a good student. And I thought, what if he was an even better student? So I typed in a higher ACT, and his price went down another $1,500. Which $1,500 may not seem like that much to you, but one extra point on the ACT made $1,500 difference, and then they guarantee that they'll keep that tuition the same for 4 years, or that gift, $1,500 off whatever tuition is, for 4 years. That's $6,000 for doing 1 point better on his ACT. So if you think of it that way, like somebody would pay you $6 grand if you do 1 point better on your ACT, you might be like, crap, I think I'm gonna study for that a little bit. So, I'm giving you a way to study for it. I have found out what is on that ACT, what are all the things they could ask you. There's only 60 questions on the ACT, but they can take from 250 different concepts that you have to know. They're not all hard. You already know many of them. There's some you probably don't know, and you're going to learn in Precalc. And there's some that you probably learned and already forgot. And what I've got here is a list of simple little things that are on the ACT, or can be. Every test, not every test. There's a ton of versions of the ACT. Every ACT is slightly different, or many ACTs are different than each other. So one person can actually get a harder ACT than another person. And another person might have been harder for them, but easier for somebody else because it happened to get questions that they didn't know. Well, anyway, here's a bunch of little concepts that you need to know for the ACT. And when I realized that the ACT was going to be really important, I started keeping the list of what are the important things kids need to know. So I got it up to 202 of them so far, and I now this summer added about 40 more that I found by looking at practice tests for the ACT that are concepts that I didn't have on my list. And so then I made a website that I already had actually, but I focused it more on this. It's called 2 Minute Teacher. I'm the one who made 2 Minute Teacher. So I have, yep, it's my thing. And so here on 2 Minute Teacher, there is all those practice problems are there. Just a second, trying to get it fit right. And those dots, I can't get rid of the dots, it's driving me crazy. Anyway, here's the practice ACT. There's version 1 of it and version 2 of it. And here's the key that you can look at that's the answers for those. And here is the videos that go with it. I made a video for every single one of the 202 problems that are there. So here's your homework for the next week. You don't have to do 202, but here's one single sheet of paper that's got front and back side. And a kid who's really good at this can finish this whole thing in 20 minutes. Okay. Somebody who's really not good at it might take you 3 hours. I don't know. Depends on how good you are at it. But these are all basic ones. And I'm hoping that this is in the neighborhood of an hour's work. And it's not due until not this week, after next week. Okay, so you have a bunch of time to work on. But if I were you, I'd start it this weekend. And let's say that you get stuck on number 2. You're not sure how to do it. You click here, and it goes to Vimeo, which is a lot like YouTube. And it's got the video there of me explaining how to do it. So, let's see if I can get it to work here.
Okay, everybody, I'm here to give you some help on question 1, 4.
And if you don't want number 1, you just fast forward through it. But it shows you how to do every single one of those problems. So, if you want to get tutoring for the ACT, that's expensive. I looked into it for my kid, and it was anywhere from 50 to 80 bucks an hour. If you want to take one of those classes, it's usually like 300 bucks. It's free for me to use. Okay, so it's me trying to help you get better on your ACT. All right, so this little worksheet I'm handing you right now is not due right away. If I were you, I'd start on it this weekend. And I'm going to ask for it, I think, by the end of next week. 3. Also, let's say you get stuck on today's factoring worksheet. Is there a way you could get some help? Yes. You can go to Schoology, where we have all the answers posted for this worksheet that I just gave you. Could you get some help on this little ACT practice thing? Yes, 2minuteteacher.com. Remember, the answers are all there. Okay, is this me trying to stump you? No, I just want you to know what's on the ACT and get good at it. Doesn't hurt our school either if you guys are good at your ACT. Schools get judged to some extent by how smart are their students. And the smarter you guys are, the better we look. It's a win-win. You get smarter, you get into the college you want, you may pay less for your tuition, and the school looks smarter too. And all it takes is a little extra studying on your part to know what's important.